Hello everyone, this is Mr. Appel. I'm going to show you how to simplify 5 times the square root of 40. So the 5 is already outside the radical, so we really just have to focus on that square root of 40 and simplifying that, just being careful not to forget about the 5. So using the perfect square method, I'm thinking of what's a perfect square that goes into 40. First thing that comes to mind is 4, so I'm going to keep the 5, and I'm going to rewrite 40 as 4 times 10. Again, we chose that because 4 is a perfect square. The square root of 4 being 2, this just becomes 5 times 2 times the square root of 10. Taking that one step further, 5 times 2 is 10, so that's 10 times the square root of 10, and that is simplest form. If I try to break that rad 10 right here down any further, the best I can do is 2 times 5, and neither of those are perfect squares, so that's as simple as it can go. If we try the factor tree method, basically what we do is we take that square root of 40 off to the side and simplify that. Let me just move this over. Whoops. Sorry, went a little too fast there. Okay. So what I'm going to do is kind of go off to the side or down below just to worry about the square root of 40. We're going to do our factor tree. That's 4 times 10. 4 is 2 times 2. 10 is 2 times 5. We're looking for pairs, so there's 2 2's. So that's a 2 that comes out. But we can't forget about this 5. That was there to begin with. And so this is 5 times whatever the square root of 40 is. Sorry, I'm kind of jumping around here. But anyway, 2 times 2 square root of 2 times the square root of 2 is just a 2. There's no more pairs left over here. So we have a rad 2 and a rad 5 left underneath the radical. They don't have a pair. So this becomes 2 times the square root of 10. But again, that's just your rad 40. I got to put that up here with the 5. So it's 5 times 2 rad 10. We can take that a step further and make 5 times 2 is 10 times the square root of 10. And we get the same answer either way. That's all. Thanks.